So today, like I mentioned today, hopefully we'll be able to cover 10.1 to 10.4. Is a lot of section, but the material is kind of connected together. But again, 10.1, which is a introduction to radical and radical function. So as you will see, this is where we would deal with a square root. So the radical, this is what we call a radical, which is a square root. A square root of a can be any number, and inside your radical, we call this a radicand, which is the item inside your radical. So again, you will hear me say your goal is to extract the radicand, which is the item inside. And that's your ultimate goal, ladies and gentlemen. Your ultimate goal for chapter 10.1 all the way to 10.4 is how can you simplify this radical expression? Okay, so again, this is not a expression. Well, it's an expression because they don't have an equal sign. But again, in terms of this item here, this is our goal, is if we have a square root of 49, how can we simplify this square root of 49? Okay, so in order for you to simplify this item here, in order for you to simplify or extract anything out, to get rid of the radical, this is what you need to know, is you need to know this perfect square. So inside your radical, underneath your radical, they can be any number, but in order for you to extract out, in order for you to get rid of the radical, you need to have a perfect square. And what do I mean a perfect square? A perfect square is basically the same number times itself. So 1 is a perfect square. And again, 1 times 1 is 1. 4 is a perfect square. 2 times 2. 9 is a perfect square. 3 times 3. And as you can look at this thing here, 7 times 7 is a perfect square. So once you identify that it's a perfect square underneath the radical, once you identify that, all you need to do is take one of them out. And that is what your answer will be, which is a square root of 49 will be 7. The simplification of square root of 49 is 7 on the outside. So if you look at this thing here, the objective for the radical is the opposite operation of a square. Again, the opposite operation of a square is the radical. Vice versa, the opposite of radical is a square. So you can see that 7 times 7 is 49, that's your 49. So the radical of 49 will give you 7. Okay, so same idea go, right? Same idea go. Doesn't matter if we have a fraction. Doesn't matter if we have a fraction inside your radical, you ask yourself, is this number right here? Sorry. I clicked the wrong item. Is this number right here, the 4, is this number 4, and is this number 81 all day a perfect square, right? So it doesn't matter how big of your radical is. Your radical can be a simple number, which is 49, like this. Or your number can be a fraction like this, but you just ask yourself, is 4 a perfect square? And hopefully you guys say, yes, 4 is a perfect square. I mentioned that earlier, 2 times 2. Is 81 a perfect square? And hopefully you guys say yes, because 81 is 9 times 9. So again, instead of say 4, we say 2 times 2, and 2 is your number. And instead of say 81, 9 times 9 is 81. As you can see, this is what you will hear me say a lot, is in order for you to extract anything out of your radical, you need to have a pair. And in order to have a pair, once you identify that you have a pair, which is there's a pair of 2, then you take one of them out. Once you identify there's a pair of 9, you take one of them out. And because it's a fraction, you take it out as a fraction. And that is your goal, ladies and gentlemen. Your goal is, no matter what's the radical I give you, no matter what the radical I give you, your objective, I cannot type this radical here. Your objective is, as long as there's a radical. For instance, if I give you a radical, let me write it out. Radical of 25, meaning a square root of 25, right? I don't have a symbolic of that radical here, so bear with me. Radical 25 is basically, instead of, as you can see right here, instead of an A, we have 25 in there, right? So again, square root of 25. So is this a perfect square? And hopefully you guys say, yes, there's a perfect square, because the radical 25, what will become an outside, common outside, or what can you extract on the outside? We know that radical of 25 is the same as the radical of 25 is the same as the radical of 5 times 5. And that's your pair, right? 5 times 5, that's your pair. What can be on the outside, or what do you bring to the outside? You can bring just one of them. Okay, so that's the idea here is, well, our goal, 7.1, or not 7, 10.1, our goal is we ask ourselves, inside our radical, is that a perfect square? Or is there any way we can bring it out in terms of that? Okay. So first of all, question with this item here in terms of this radical item, ladies and gentlemen. So let's take a look at this thing here. Give me 1 second. So let's see if let's skip this for now. Let me share you this item here. So if you look at this thing here, let's take a look at this item. For instance, same thing go with example one, right? And they ask you to simplify. So let's practice. Let's say if I give you this item here, we have A, B already. Let's do C. If I give you this radical, you know, it's hard for me to type it up. Let's say if I give you this radical and 121. So if you look at this thing here, 121, this is what you ask yourself is 121 a perfect square, right? So if you agree, or if you look at this thing here, do you agree that 121 is the same as 11 times 11? And 11 times 11, right? 11 times 11, that's what we have, 121. And 121 is a perfect square. And if you identify that they are the perfect square, you can see that we have a pair of 11. And if you simplify this thing here, one thing is, ladies and gentlemen, you have a pair, and when you take it out, you take out only one of them. Please, please, please do not do this. A lot of my previous students, this is what they do. Again, our goal is we want to extract this thing out. We want to get rid of the radical. Do not take the 11 out and put them in another radical. Okay, this is a no. We do not put in another radical once you extract them out. Your goal is to extract them out, and once you extract them out, that is your answer. Okay, so let's take a look at D. Let's say if we have D. And again, let's say if I have a square root of 64 here. So again, clearly, hopefully, again, I did not mention this, but if you want to, this is your perfect square. Later on, you will see that I have it up for you, that this is your perfect square in terms of the number that you want to remember. This is your first 12th number. Again, 1 is 1 times 1, 4 is 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8. So if you look at this thing here, we can see that this item, 64, is a perfect square. And if this is a perfect square, basically they ask you, what can you bring to the outside? And again, we can see that this is our perfect square. 8 times 8 is a perfect square. And if you want to bring it outside, you can only bring out one of the 8. Do not put it under the radical again, your goal is you get rid of the radical, and to get rid of the radical, to get rid of the radical, we simplify the perfect square. Okay, so now question here in terms of how to simplify your radical. Now to go back to our problem. So if we have a number, then that is easy to recognize. If we have a number, if we have a square root of 144, that is easy. We take out a 12. If we have a radical of 15, we know that is easy. 4 is on the outside because it's a perfect square. What happens if we have a variable on the inside? What happened if we have an x squared? So if you remember earlier, let me ask you this question. Is this the same? Is this two item the same? X squared is the same as x times x, or x to the 1 power times x to the 1 power. And again, if you say no, we are in trouble, right? Remember to multiply the exponent, or to multiply the base, we add the exponent. So this item right here, we can see that we have 1x times 1x, or x times x, to give me x squared. And if to go back to our definition of radical, do you agree that we have a pair of number inside your radical? And if we have a pair of number inside your radical, what can you take outside? You can take one of them to the outside. Okay, so this is what we have. No matter what they give you, our goal is, again, you can see that this thing right here, is 8 square. 8 square, 8 times 8, 64. So again, and if you remember, I mentioned that the square and the square root, they cancel each other out. The square and the square root, they cancel each other out. But let's go back to this thing here. If I were to give you this item, let's say a square root of x to the 8, okay? So one thing I want to point out, and this is the one thing that a lot of students have problem or difficult item. One thing is, make sure x to the 6. No, that's the 2. That's the 2, not the 12. Last time my problem with x to the 2nd power, not x to the 12th power. So yes, if you have x to the 6, then x to the 3 will be your answer. Someone type in the chat. That's why I tried to answer. But let's take a look at this thing here. Well, let's take a look at. Let me finish this thing here, and hopefully you guys see the item is. So one thing I want to point out to you guys, or one thing that you guys need to remember, or let me go to this thing here so that we isolate it. Ask you, hopefully you guys see the difference in terms of this number 16 as a constant versus this number 8 as a power. Everybody see that this two number 16 by itself, that is your constant. And if you have a constant, you ask yourself, is there a 2 number, or is there 2 number, or 16? In this case, 16 is a perfect square. Why is a perfect square? Because we know that it's 4 times 4. And if it's 4 times 4, or as you can see, 4 to the 2nd power, the power and the square root, they cancel out, so you only have 4 left. okay? So now to go back to this item here, if you recognize that this 8 is not a constant, and if that 8 is not a constant, then this is what you want to do, or this is what I want you, that the power and the square root. The square root is basically tell you whatever power that you have, you divide that by 2. I repeat again, the square root basically tell you whatever power that you have, you divide that by 2. So if you look at this problem right here, I told you that the 16, we can say 16 is the same as 4 raised to the second power. And 4 raised to the second power, everybody see that 4 raised to the second power, what do? We take the power, divide that by 2. And what is 2 divided by 2? Well, 2 divided by 2, everybody see that is 4 to the 1 power, because 2 divided by 2, that's what you have, is 2 over 2 is equal to 1. So this is what I want to tell you, that later on you will see that whatever the power you have, the square root tell you take this item and divide it by 2. Whatever power is, you divide it by 2, or the power over the root. You will hear me say that a lot. Power over the root. Root, and why do I say root? Because it's divided by the second power. Okay, so to be in short, ladies and gentlemen, to be in short, whenever you have a power and then they ask you to take a square root of this thing here, all you do is you divide this 8 by 2 to give you x equal to x raised to the 4 power. Okay, so that is what the power, and that's why I focus in and ask you guys to determine, to ask yourself the difference between the power versus the constant, right? There's no exponent here in terms of the 16. In terms of the 16 over here is not an exponent. If they have a 16 like this, for instance, let's say G, if they give you a square root of y to the 16, if they ask you this thing here, and again, ask yourself, what is this 16? Is that 16 a constant, or is it a power? Okay, so again, that's what you need to ask yourself in this case here. This 16, is this 16 a constant, or is it a power? And as you can see, we say y raised to the 16, or the power of 16. So everybody see that these two items are not the same. One of them is a whole number, 16. The other one is the 16 in terms of the power. And please distinguish that different, because if the 16 is the power, to simplify this thing here, you just need to take 16 divided by 2. And 16 divided by 2, everybody see it, y to the 8 power on the outside. Okay, this thing here, you need a perfect square. And a perfect square is 4 square, and again, the answer is 4. So again, a lot of my students, they saw that y to the 16 and they say, oh, square root of 16 is 4. The answer is y to the 4 is not, because the 16 is the power, and to get rid of, to simplify the power, you just need to divide that by 2. The power does not have to be a perfect square, meaning if I give you something like this, z to the, let's say 22. Again, 22 is not a perfect square. 25 is a perfect square. So again, we don't care if this power is a perfect square or not. To simplify this thing here, all you need to do is take 22, divide that by 2, and 22 divided by 2, you can see that z is, okay? So to be in short, all we're doing is to simplify the power for the square root. All we need to do is divide that power by 2, okay? So let's go back to this thing here, which if you look at C, and again, I know I go off in the in the wrong alphabetical order because I have H on the other side, and now we go back to C. If you take a look at C here, if you look at C and they ask you what is a square root of x to the 14. And again, this 14 is not a perfect square, and we don't care if it's a perfect square or not because that is your power. And hopefully you guys say, oh, because it's my power, all I need to do is divide the 14 by 2. So my answer will be x to the 7. Okay, so again, this thing here, I type it, as you can see, we're looking for a pair of the same. In order to get out of the radical, your radical have to be a pair of the same item, and the pair of the same item will be x to the 7, x to the 7. Once you have a pair, one of them to go outside. Or to be in short, if you have an exponent, you divide your exponent by 2 if you have a radical. Or not radical, a square root. Now, let's take a look at this problem here. So one thing is, as you can see, one thing is we go in, or they go in and they say, well, if we have a perfect constant, that's easy. If we have a perfect constant, that's easy. If we have a exponent, that's easy. What happens if you have a constant and the exponent? So do you agree that if you have this thing here, is 36 a perfect square? Right? That's what you ask yourself. Is 36 a perfect square? And hopefully 36, you say 6 times 6 is 36. So because 6 times 6, I can take out one of the 6. And the 12, all I need to do is divide that by 2. And the 22, we did this. We divide that by 2. So my answer will be 6 as a whole number, x raised to the 6, y raised to the 11. Again, distinguish your constant versus your exponent. In order to get rid of the constant have to be a perfect square. In order to get rid of the exponent, you just need to divide it by 2 if it's a square root. Question with the radical here, or a square root. Now, you say that this item here is a little bit different. Instead of a square root, what happens if they have a 3 here? What does this mean? Well, the 3 is tell you that this is a cube root. And what does the cube root mean? Well, if it's a square root, we're looking for a pair of 2. It's a square root, we're looking for a pair of 2. The cube root, we're looking for a pair of 3. And you can see right here, 2 times 2 is 4, 4 times 2 is 8. So the 8 is a perfect cube. The 8 is a perfect cube. And if I have a pair of 3 number, what can go outside? We can see that if we have a pair of 3 number, one of them can go outside, which is in this case, we have, or we can take out a 2. Okay, so to be in short, this is very unique. And let me take a look at this thing here. I don't think I break it down. Let's take a look at this item. So we have 64, cube root of 64 x to the 18. So if we have a cube root of 64 x to the 18, what do we do? How would we go about to do this problem? Cube root of 64, right? So we have a cube root of 64 x to the 18. So think about this thing here, ladies and gentlemen. Think about this thing here. And again, for now, you probably don't see the 64 as a perfect cube, but let me ask you all this question. Do you agree that 4 times 4 is 16? And 16 times 4, that will give me 64. And again, 64 is unique. 64 is a perfect cube. Why is a perfect cube? Because 4 times 4 times 4, 3 times. That is where my perfect cube come in. I have 3 of the same. And the perfect square is 8 times 8. be careful of which one they ask you. Is do they ask you for a square root, or do they ask you for a cube root? If they ask you for the square root, it's a square root of 8, or if they ask you for a cube root, is 3. So similar to this thing here. Let me this way. Everybody see that we did this right here, right? We say 4 times 4 times 4, which is the same as 4 raised to the third power. So 4 raised to the third power is equal to 64. So let me write it this way to illustrate to you guys. Remember, we have a square root. If there's no number in front of this thing here, it's assumed to be a 2. That's your basic number. If you have just a radical, that is your square root. If you have any number, if you have a 5, we say it's the fifth root. If we have a 7, we say that is the 7th. Okay, so if you square root, what do? We divide the power by 2. So similarly, if it's a third or a cube root, what do we do here? Well, basically, all you need to do is take this thing here and divide it by 3. A square root, we divide by 2. The cube root, we divide by 3. The 4 root. Okay. In this case, everybody see that I shouldn't put this. This is a wrong notation. Once you divide by 3, there's no longer a root in there. So that's the wrong notation you have. As you can see, 4, 3, and 3, that's equal to 1 to 6. So your answer here is x to the 6th, 4 times x to the 6th. Okay. And then let's try. I know you guys are a little confused. Let's take a look at this thing here, and let's say the next example, i.e., let's say cube root of 125 x to the 27. Okay. And again, let me give you the perfect cube. 1 is very unique, guys. 1 is a perfect in every form. 1 times 1 times 1 times 1, forever you still get 1. So 1 is a perfect square, perfect cube, perfect 4, perfect whatever you want it to be. Okay. 64, 125, 216. This right here is a perfect cube in terms of 2 times 2 times 2, which is 2 to the third power. This thing here is a perfect cube because it's 3 times 3 times 3, which is 3 to the third power. This thing here we just did is a perfect cube because it's 4 times 4 times 4. This thing here is a perfect cube because it's 5 times 5 times 5. And this thing here is a perfect cube because it's 6 times 6 times 6. Okay. So again, one thing is there are 2 ways to do this radical item is you either remember your perfect square and your perfect cube. And most of the time, perfect go, 216 is pretty the highest they want to go. The next one, if you want to 49 times 7, 49 times 7, 343. If you 343 is a perfect cube because 7 times 7, but rarely they ask you something beyond this item here, 216. But looking at this thing here, because we have a perfect cube, you ask yourself, or not because of a perfect cube, because of a cube root. Because of the cube root, you ask yourself, is this number, is this constant? Is that a perfect cube, right? Is that a perfect cube? So again, because of this thing here is a perfect cube that we have, it's perfect because it's 5 raised to the third power, right? We illustrate on the other side, that is what of 125. Instead of say 15 is the same as 5 raised to the third power because 5 times 5 times 5. And now how do we simplify this thing here? It's just the power over the root, the power over the root. So all we're doing is we divide this thing here to give me 5, x to the 9. Okay, so that is one way to do this item. One way to do this item is you see that they are a perfect item, or if not, this is what we have. Let you know, I don't know, you know, sometime x to the 20. One thing is you know, I jump back and forth of this item here. If you can see, you know, 125 is the same as 5 times 5 times 5. X to the 27 is the same as x to the 9, x to the 9, x to the 9, because 9 plus 9 is 18. 18 plus 9 is 27. And I mentioned to you guys that because of the Q root, we're looking for a pair of 3. And if we have a pair of 3, we can bring out one of them. So again, 5 times 5 times 5, 3 of them, I can bring out 1 5. And x to the 9, x to the 9, x to the 9, 3 of them, I can bring out 1 of x to the 9. And that is my answer, 5x to the 9. So again, no, doesn't matter how you look at this thing here. You either take the power divided by the root, or you're looking for a pair of the same thing. Okay, so to go back to our problem, if you look at this item here, if you look at f that we have, see that way, because it's a Q root, because I'm looking for a Q root, and in this case, because of the Q root, I'm looking for 3 of the same. So again, 64 is a perfect cube because 4 times 4 times 4. 18 is not a perfect cube, but 18 I can divide this by 3 to give me x to the 8, 6, x to the 6, x to the 6. And because I have a pair of 3 number, I can bring out one of them, which is I can bring out 1 of the 4, 1 of the x to the 4, to the 6. No longer, again, ladies and gentlemen, no longer, if you look at this thing here, no longer do I have a radical. Your goal is you want to simplify this item by take out the radical. Once you take out a radical, that's it. You do not put inside another radical. Okay. So let's see. Do I have another problem? I do. First of all, before we go to the next one here, question. Any question here, ladies and gentlemen, question with how to simplify your radical here. So one thing I want to point out, is looking at this thing here. There is a, if you look at this item, and again, 27, negative 27, 27 is a perfect cube. Negative 27 is also a perfect cube, and because it's a cube root, we're looking for a pair of 3. Negative 3 times negative 3 will give me a positive 9. Positive 9 times a negative 3 will give me a negative 27. So as you can see, negative 27 is a perfect cube. And again, like I keep on mentioning, all we're doing is we take the power divided by the root. And if you take 6 divided by 3, 12 divided by 3, and 3 divided by 3, that is what you have is 6 divided by 3 to give you 2, 12 divided by 3 to give you 4, and 3 divided by 3 to give you 1. Okay, so again, the power, we take the power divided by the root. And again, this thing here is the same as negative 3 raised to the power, and the third, which is 3 over 3, is equal to 1. So question with this particular problem G here, ladies and gentlemen. So here come, it is a lot of difficulty. You have to ask yourself, what kind of root do I have? And if it's the Q root, like before, we good. But in this case, this is a square root. Is there two of the exact same number multiplied together to give you a negative 121? And again, there is no 2 of the exact number, because in order to get a negative, one of them have to be positive and one of them have to be negative. negative 11 times negative 11 to give you a positive 121. Positive 11 times positive 11 to give you a positive 121. There is no number, there's no two of the same number multiplied together to give you 121. Okay, so distinguish the difference between a cube root and a square root. Because in order for you to get negative 121, one of them is positive, the other one have to be negative, because 11 times a negative 11, that's what or how you get negative 121. So for now, as long as you have a square root of a negative number, we say no solution. There is no way you can find a number that you can take a square root of this thing here and you get a negative number. For now, if you have a square root of any negative number, we say it's undefined or no solution, no real number. Okay. And again, you say, wait a minute, wait a minute, right? Why does down here we have a solution? Why does this is a solution? Because this thing here is not a square root, but it's a cube root. And the cube root, the odd number, we have a negative. Okay. This is even number. We won't have a, we cannot multiply even number and get a negative. So let's jump to 10.3. 10.3, again, we go back to 10. We kind of did 10.2. It's just I did not mention what 10.2 is. We kind of did it. We'll go back to 10.2 in a bit. But let's take a look at 10.3. And 10.3, we have a product of a radical. And again, the product of radical tell you this. In order for you to multiply two radicals together, the radical have to be the same. So if you have a square root, you need to multiply with another square root. If you have a cube root, you need to multiply with another cube root. You cannot take a square root and multiply with the cube root. Or you cannot take a cube root, multiply to the fifth root. Okay, so basically whatever the root is, in order for you to multiply, your root have to be the same. And if your root is the same, all you need to do is take the number, the radican, and multiply to each other. You kept the root and you multiply the two radican. Okay, so again, no matter what you have, for instance, look at this item here. Looking at this item here, everybody see that we have a square root of 25 times a square root of 25. So square root of 25 times square root of 25, we can do it. We can multiply them together. Or if, again, this is what I should type in first, which is a square root of 25 times square root of 4. They have the same square root. All you need to do is multiply the two items together. So multiply the two items together, which is 25 times 4 to give you 100. And what is the square root of 100? Well, the square root of 100 is 10. So again, the idea or the rule of this thing here is in order for you to multiply, they need to have the same root. They need to be either both of them square or both of them cube root or both of them full root or whatever the root that they give you, that they have to have the same root in order for you to multiply. And if they have the same root, all you need to do is multiply them together. And again, the reason why I show you this item here, is I want to show you that they hold the same property. Basically, if you can simplify and multiply, it's the same as you multiply and then simplify, right? What is a square root of 25? Well, a square root of 25 is 5. What is a square root of 4? A square root of 4 is 2 because those numbers are perfect square. And what is 2 times 5? Well, 2 times 5 is 10. So the only reason why I give you this two items just to show you that they hold that commutative or associative property. Meaning it doesn't matter. Doesn't matter which operation you apply first. You can simplify, take it out of the radical and multiply. It's the same as you multiply them and take it out of the radical. They give you the same answer. Okay. So looking at this item here, let's take a look at, and this is where we have in the sense that sometimes you want to multiply them first and then simplify. So the quotient rule is the same, very identical. It's basically tell you that if you divide in order to mush them together, they need to have the same root. As long as they have the same root, you can mush them together or you can take them apart. Okay, so we did this earlier. It's just that I did not mention about the rule that you have. As you can see right here, the two root 100 and square root 100 and square root 4, you can merge them together, which is 100 divided by 4 to give you 25. Square root of 25 is 5. Or if you don't like to do that, you can take the individual, which is a square root of 100 is 10. Square root of 4 is 2. Well, 10 divided by 2, you still have 5. This thing just to show you that the two rule, the product rule or the quotient rule, is cumulative, meaning doesn't matter which item you simplify first, your answer is the same. Okay, so let's take a look at the problem. As you can see right here, the problem as you have is square root of 50. So one thing about this thing here, you will say, why, wait a minute, Mr. Tran. 50 is not a perfect square. I agree with you, 50 is not a perfect square because 49 is a perfect square. 49, which is 7 times 7. So as you can see right here, the challenge of this item, the challenge of chapter 10.3 is there a perfect square in this item? Okay, and as you can see, there is a perfect square, right? 25 times 2. And 25 times 2, do you see that the radical rule or the multiplication rule is basically tell me that if we have two items in one radical, we can split them out. Radical of 25 will be 5. The radical of 2 will be just 2. So we have 5 radical 2. So again, your problem, your objective for this particular problem in 10.3 is, can you identify the perfect square, right? So if you can identify a perfect square, 24 is not a perfect square if you look at B. 24 is not a perfect square because 25 is 24. There's no 2 of the same number multiplied to give you 24. But is there a hidden perfect square? Is there a hidden perfect square? Do you agree that 4 times 6 is 24? Why do I use 4? Because 4 is a perfect square. Some of you guys say, what about 12? Well, 12 is not a perfect square, ladies and gentlemen. 9 is a perfect square. 16 is a perfect square. But there's no number multiplied 9 to give me 24, and there's no number multiplied to together, whole number, I should say, multiplied to give me 16 to give me 24. The only two whole number multiplied to give me 24 is 6 and 4. And why do I use 4? Because 4 is a perfect square. What is the perfect square of 4? Because there's a 2. 2 times 2 is 4. So I can bring out a 2. And I divide by exponent, my power, I divide by a square, which is divided by 2. So again, 24 divided by 2 to give me x to the 12. My long list 6. My long list 6 is not a perfect square. So if they are not a perfect square, they stay on the inside. Okay. So let's take a look at this thing here. So what happened if we have something like this? 54, 13, 7. What happened if we have something like this? So how would we go about to simplify this problem here? How do we simplify this problem here in terms of C, a square root of 54, x to the 13, y to the 7. So let's take a look at 54 first. Let's dissect one at a time. What is a square root of 54? So one thing I thing that for what I do a lot is I break this 54 down to, I break it to a problem. If I see a perfect square, there are two methods I should say. Let me do this method first. So 64. If you look at this thing here, what is this number that I roll over here? This is my perfect square number, right? One way to do this in German, one way to do this is all you do is you take 54 divided by, as you can see, 54 cannot divide by 64 because again, 54 big number divided by 64 is will not give you a whole number. It will give you a decimal. So what you do is you take your calculator and you take 54 divided by 49. As you can see, this thing will not give you a whole number. So we know that this item will work out. You can take 54 divided by 36. And why do I do this? Because I don't know what is the perfect square there is. So in order for me to do this, I want to take 64 and divide by the maximum number, divided by the maximum whole number I have. Okay. And if you look at this thing here, if you don't see it, this is the, you can try the 25, you can try the 16, but the one number that you will see, the one number of 54, 54, do you agree that 9 times 6 is 54? And why do I use 9? Because 9 is a perfect square. And if it's a perfect square, I can bring it to the outside, because if it's a perfect square, I can bring out 3, and that's what I have left, right? That's one way to do this item here, is you can take your number and divide it by a perfect square number. If you don't want to do that, the other way, and we will do this a lot tomorrow, the other way is we want to break this out to be some multiple. And if it's a whole number, everybody see that if it's a whole number, I can take this number and divide it by 2, because any whole number I can divide by 2. And if you look at this here, if it's an even number or the odd number, I can divide it by 3. So if you take a look at this thing here, we know that 3 times 9 is 27, and 9 I know is 3 times 3. So anything that have the line underneath, I do not look at, right? So look at here, I just look at this item here, number 2, number 3, number 3, and number 3. And because of a square root, everybody see that because of the square root, I need to looking for a pair of something. And if they are a pair of something, one of them can go outside. And what is my leftover? My leftover is 2 times 3. And what is 2 times 3? Well, 2 times 3 is 6. And it's the same answer as that. Okay, so one way is you can take your number and divide it by a perfect square, which you have to know what your perfect square number is. Or the other way is you just break this item down, smallest item, right? Break it by 2, break it by 3, break it by 5, break it by 7, break it by 11, break it by 13, right? Break it down until you cannot break it down any further. And then because it's a square, we're looking for a pair of 2. So question here in terms of this thing here, the 64, I can reduce that to 3, and the 6 is a longer number on the inside. Okay. I need more space. So what about this 13? What about that 13? If you look at that 13, this have is, again, we can take the individual item, right? We can take the individual item out because the rule tell me that if they multiply, we can take individual item and put it in a square root. So square root x to the 13. And if you remember, x to the 13 is basically the power divided by the root. And in this case, the root is the 2, the second power, right? Not the power, the square root, because it's a root is 2. So if we divide this, do you agree that this is what we have? Is we have x, let me do this way, x to the 6th times x to the 6th times x to the 1. Do you agree that in chapter 5, you know, x to the 13 is basically x times x times x times x times x 13 times, right? And x times x times x 13 times is the same as x to the 6th power times x to the 6th power. Because x times 6, x to the 6th power, x to the 6th power, that will give me x to the 12th. I have a 1 extra because I have actually, because x to the 6, x to the 6, and there's 1 extra, that's why I have x to the 13. So if you look at this thing here, you will say, oh, look at this thing here, what can come out? What can go outside? Well, we can take 1 of the x to the 6 outside, and this is your lonely number x, okay? And you would say, wait a minute, Mr. Trent, I divide this, and this is what I have. You divide this 5. And because that's a 6.5, or because of this 0.5, because of that 0.5, this is where the 0.5 come in, ladies and gentlemen. That is your leftover, or that is your remainder. Again, if you divide this item here, you will see that we have a remainder of 1. And because the remainder of 1, there is 1 lonely number on the inside. Okay, so again, how many x can you take it to the outside? What is your whole number? Your whole number is 6. And again, there is 1 left over x. How many y can you take it to the outside? If you divide this by 2, y, and left you with 1 of the y on the inside. Okay, so this is what we have is again, let's take a look at this thing here. Let me give you, I will go back to that problem. Let's say if I give you this example here. Let's just practice this example. Let's say if I give you a square root of a to the 23rd. Again, I give you this problem before, and well, we give you some before, right? Z to the 22nd. And if you remember, the 22nd is an even number, and even number divided by 2, you will get the whole number, right? Z to this thing here would give us Z to the 11 because they will divide by 2. So one thing I want to point out to you guys, that if you divide this by 2, because 23 is an odd number, and the odd number divided by 2, you will always have this, ladies and gentlemen, you will always have 22. You don't have to. You will always have this thing here. You will see that you have 11.5. And what is the 11.5? Well, the 0.5 is the leftover, or in this case, you can see that if I divide this in as a long division, I bring down the 3, I divide this as a long division, there is a remainder of 1. And what does this remainder of 1 hold? Well, the remainder of 1 basically tell you the whole number. This is your whole number. The whole number is this, which is, that is what you can bring it, is what is left over. Remainder of 1 is what is left over, and that is your answer here. You rarely see that it's over 1 or raised to the 1 power. just basically you will see a lot of this item here. And again, same thing go. Let's say I go back to this x, right? X to the 17. If you take x to the 17 and you divide this by 2, you can see that how many x can you bring it to the outside? Again, if you divide this by 2, you can see that 8 times 2 is 16, and 17 minus this, you will have 1. You will have one remainder, which is this is your whole number. Your whole number is the power on the outside. Your remainder is the power on the inside. But again, because it's a remainder of 1, we don't really need to write it, which this is your answer. Okay. So again, basically you ask yourself, regardless of what they give you, they can give you something like this: a to the 5, b to the 19, c to the 27, right? So basically, as long as the square root, as long as it's a square root, we need to divide this by 2. We need to divide this by 2, and we need to divide this by 2. And if you look at all this thing here, all of this number is odd number. And if you divide any odd number by 2, you will always have one remainder. Regardless of what you have, as long as you have an odd number and you divide by 2, you will always have a remainder of 1. So again, how many a can you bring it to the, as you can see, second power? How many b can you bring it to the outside? You know the b to the 9 power, because 2 times 9 is 18. How many c can you bring it to the outside? Well, 26 divided by 2 will give me 13, right? So in this case, you have 1a, 1b, and 1c. There will always be one left over on the inside, okay? But we don't write 1. We just know that there is a lonely number. There is a lonely leftover number. Okay, so if we go back to this problem that we have, before, let me erase this to make a little bit. If you look at this thing here, square root of 54, x to the 13, y to the 7. So again, that's why we still have a one lonely number x and one lonely number y. Please, ladies and gentlemen, please, the 54 is not the power. Do not say 54, I divide that by 2. Again, 54 is a constant. So if it's a constant, you have to ask yourself, is there a perfect square? Okay. So if we go back to this item here, you can see that this is what we're doing here. Is again, I did this earlier, which is 9 times 6. Why do I use 9? Because 9 is a perfect square. 13 divided by 2, I have 6.5. I take out a 6. The 0.5 is the leftover. 7 divided by 2, I have 3.5. I took out the 3. The 0.5 is the leftover. Okay. Looking at this thing here, what happened if we have this? Well, first of all, question with C, ladies and gentlemen. Now, let's take a look at D. So we did the square root a lot, right? And let me do this thing here. Let me, no, let me share you. Before we look at that problem, let me ask you this question. Let's do this thing first. Forget about the problem I have on the screen earlier. Let's take a look at this item. Let's say, an example, q root of x to the 5th power. Okay, so what is the q root? What is the q root? And again, hopefully you guys see, basically we take my power is 5 and we divide that by the root. And in this case, we take this thing here, we divide it by the root. okay? But before we do that, and again, I will illustrate this a little bit later, but do you agree that this is what we have here? X time X time X time X time X. Do you agree that X to the phi, let me erase all this thing here. I will go back to this item. Let me illustrate this problem this way. Do you agree that X to the phi power, the phi power tell me whatever my base is, write it 5 times. 1, 2, 3, 4, 5. That is where my phi power tell me to do is whatever my X, whatever my base, I write it 5 times. And if you remember, what is the Q root? What is the Q root here? Well, the Q root, in order for me to simplify the Q root, I need to have a pair of 3 of the same. So I have an X, I have an X, I have an X, I have 3 of them. I can bring it to the outside, which is I can bring out 1 of them. What is my leftover? My leftover, do you agree that my leftover is 2 of the X? My lonely, well, not really lonely, but my 2X that I don't have a pair. In order for me to get out of the Q root, I need a pair of 3 of the same. And if I have a pair of 3 of the same, them outside. I don't have 3, I still have a lonely 2 item inside, which in this case, I can simplify this thing here as that. I have an X Q root of X squared, okay? So let's try, and I'll go back to that a little bit. Let's say same thing go, right? Let me change the color so that, let's same thing go. Let's say if I have, let's do y to the 11, okay? If we do y to the 11, do you agree that elementary, we can break it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Elementary y to the write the y 11 times. And based on this thing here, if I see a pair of 3, I out 1 of them. If I find a pair of 3, I can bring out 1 of them, which is I can bring out 1 y. I can bring out 1 y. I can bring out 1 y. Left me with this item here. So again, 3 of them go out 1, 3 of them go out 1, 3 of them go out 1. So if 3 of them go out 1, do you agree that y times y times y is y to the 3rd power? And the Q root of y squared, which is I have 1 item left, 2 items left. Right? So elementarily, this is what we can do with, we can break it down and we can look at the pair of 3. We can look at the pair of 3, and as long as they have a pair of 3, I can bring it to the outside. But what happens if we have something like this? Q root of, let's do C to the 31. I don't want to write C 31 times, and hopefully you don't, right? I don't want to write C times C times C times all the way to 31 times. So what do we do if the number is humongously big? Well, the number is humongously, not really that big, but if you remember, this is what we have, is we have the power divided by the root. And again, this is my root. I have a Q root, and this is my power. I have a 31 power. So if you divide this thing here, ladies and gentlemen, and again, I want to, if you divide this, do you agree that 3 go into 31 is 9 times? Well, not 9 times, sorry. 3 go into 3 is 1 time. And again, I bring down my 1. 3 going to 1 is 0 time. And again, do you see that we have a remainder of 1, right? This is my whole number. If we connect this item here, this is my whole number. My 10 is my whole number, right? And my 1 is my remainder. My 1 is my remainder here. So what do we do, or what do we know? If you remember your whole number, is what you outside. And again, your remainder is what you have on the inside. Your remainder of 1 you have on the inside, that's what we have. We connect this thing here to the previous problem, and this is what we have. And you would say, wait a minute, Mrs. Tran, right? Why does this item is a 2 and why is this item is a 1? Right? That, look at this, right? Let's go back up here. What do we have here? We have 3 divided by 11. And 3 going to 11 is 3 times, and 3 times 3 is 9. And do you agree that this is what we have? We have the remainder of 2 and the whole number of 3, right? So sy, the whole number, this is my whole number, the 3, and this is my remainder. The remainder is still on the inside of your radical. Okay, so given this, let's take a look. Say I'm here. Let's say if I give you a Q root, let's say Q root of, let's do x to the 29, y to the 13. So looking at this item here, we know that it's the Q root, and the Q root tell me that take this power divided by 3. If it's a square root, I divide it by 2. And if I divide by 2, if it's an odd number, there's always 1 remainder. But if I divide it by 3, ladies and gentlemen, if I divide it by 3, you can see, let me do it this way. 3 divided by 29. Do you agree that 3 going to 29 will give me 9 times? Because 3 times 9 is 27. And 27, do you agree that this is the remainder of 2, and the whole number is 9? And if this is the case, do you see that how many x can go outside? There is 9 of them can go outside. What are how many x on the inside? There are 2 of them on the inside. Your remainder is what is on the inside. Your whole number is what you can bring it to the outside. Let's do by 13. If 3 divided by 13, we can see that 3 going to 13 is 4 times. And again, 13 minus 12, because 4 times 12, we know that this is the remainder and this is your whole number. And what is the difference between the whole number versus the remainder? Well, the whole number is how many y can you bring it to outside? The whole number tell you that you can bring out 4 of them. And the remainder, what is the remainder is what is left on. So in terms of this thing here, this is what we have is we have x to the 9 power, y to the 4 power. There is a q root of x to the 2nd and y. So again, that is what you have. And one thing is you see that you say, Mr. Tran, I type this thing in my calculator. I type this thing in my calculator and my calculator give me 9.66666666667, right? And if you type this in your calculator and your calculator tell you that this is 4.333333333333, right? What does that mean? Well, because it's 1, the remainder of 1 over 3, the remainder of 1 over 3, that's why you have 0.3333333. and the remainder of 2 over 3. That's why you have 6, 6, 6, 6, 6, 6, 6, 6. So if you want to remember that way, if you divide it by 3 and you have a decimal in 6, 6, 6, 6, 6, 6, meaning there's a remainder of 2. If you have a decimal of 3, 3, 3, 3, 3, 3, then that is the remainder of 1. So if you want to remember that way, that's perfectly fine. But we will do this again. Our previous problem, before we run through all of this item, this is your previous problem, which is the cube root of 24 v to the 19. So if you look at this thing here, if you look at here, hopefully you guys see that this is 8 times 3. 8 times 3 is a perfect cube, which is 8 is 2 times 2 times 2, right? And 3 divided by 19, hopefully that you guys see that is 6. And there is a remainder of 1, okay? So if we see that, if you look at this item here, let's go over this item, the last item we have. And if you look at this thing here, you can see that that is what I have, in the sense that I have 2 on the outside because the 8 is the 2 times 2 times 2. And 6 is a whole number. That's why V2 is 6 on the outside. And the remainder of 1, there is 1 longly V on the inside. Okay. So again, some of you probably have a few questions here and there. Let's stop here for today.